How to survive a saltwater crocodile attack. So basically, saltwater crocodiles are one of the deadliest animals in the ocean and one of the only animals that actively hunt and eat humans. That does not mean they don't deserve love or respect. It just means they deserve all of that from a distance. Now, basically, about 60% of all attacks with crocodiles are fatal. So here's how to maybe make that number less than 60%. So basically, go for the eyes. Crocodiles' eyes are extremely important to them as they are sight hunters and they're extremely protective over them. So if you try and gouge out one of their eyes, they'll probably let you go and swim away, which is good. Also, it's okay to lose a limb. As morbid as that sounds, multiple interviews with people who survived attacks basically had to sacrifice a limb in order to escape a crocodile's jaws, so that's good. Also, avoid the head and tail once you've been bitten, because that can further increase either getting knocked unconscious or being bit even more, which can lead to more injuries. Also, do not run in a zigzag. They can run at 10 miles per hour, and running in a zigzag does absolutely nothing. At first, back away slowly, and then just sprint as fast as you can in a straight line to avoid them. So yeah, good luck.
Okay, now, oh boy, my voice is really high this time. Oh, well, you can tell I have a lot of fun with playing around with these gases, but not as much fun as the next one that I have here. Now, you've obviously seen that this balloon here, this blue one, was filled with something that was very dense. And you'll see here that when I let go of it, you've maybe heard of the lead balloon. Well, this is the proverbial lead balloon. And this balloon is filled with an extremely dense gas called sulfur hexafluoride. Now, sulfur hexafluoride has a density which is 5 times greater than air. In other words, its molecules are 5 times heavier than corresponding air molecules. And they also happen to be, in case you're interested, about 35 times heavier than molecules of helium.
Something we understand but absolutely refuse to accept.
I believe this is my time to shine. You, my friend, are not a human being. You are a being experiencing human. Everyone, all together now. Touch something. Boop. You are not that confirmation. I felt that. In the sentence, I felt that. You are the I. Felt that is just the mind and body's confirmation of experience in thought form. You are experiencing. Therefore, the experience of touch, physical confirmation through thought, confirmation of thought from you, your confirmation of experience through senses, leaving you confused of experience, leading you to believe that you were experience itself, making you deem yourself human. Stay centered and remember, it is cool to use this body, but don't let it use you.
Cool trick with these crystal beads I got from the dollar store. So I'm gonna start by opening these up. I'm gonna open this up and I'm gonna, oh, these smell good. So I'm gonna pour them out, oh, in here. Just like that. In this clear bowl. I'm just taking out the blue orbs out of here because we only need the clear ones. Took all the blue ones out and I just have the clear ones in here. Closely, what happens when I add water to the clear beads? They disappear. Look, it just looks like an empty bowl of water, but as soon as I reach in, I got my Orbeez. Try this for yourself.
Amazing thing that you can do with the super cold water. Stream just instantly turns into ice. Look, as soon as it touches right there, it even like goes up the stream. I wonder if it'll go up. Oh, it went up into the bottle. Look, the entire bottle is now turning into ice.
Think smart, not hard. This is gonna smell pretty minty. Yes, let's get the magnets. I'll use this one instead. Got some dirt. And we're back, and I changed my mind. Let's use a bowl. Add a little bit of water. That took forever. I should have just chewed it. Now we add the magnetic ingredient. I think it should be enough iron for the magnet. All right, here goes. Oh, it works. Oh.
Tell me something that is totally normal, but seems completely unacceptable. I've never been able to understand the way that people can accept believing in something based on faith. Faith is not a good thing. Faith is not a virtue. Faith is the excuse that someone gives for believing in something when they have no good reason for believing in it. Because if they had a good reason for believing in it, they wouldn't have faith. They would have proof. They would have evidence. Either evidence for something's existence exists or it doesn't. There is no middle ground there. And yeah, the absence of evidence is not the same thing as the evidence of absence. Just because I can't prove that something does exist doesn't necessarily mean that it doesn't. But what you don't get to do is flip that around backwards and say, you can't prove that it doesn't exist, therefore I'm going to assume that it does. That's not logic. That's what crazy people do. If I tell you I have a magic goblin living in my closet that disappears whenever anybody looks for it, you can't prove that that's not real. But are you going to believe it though? Like, I don't have my own reality. I just live in reality.
How far can a full tube of toothpaste go? I don't know if it's just me using too much of this stuff, but it seems to run out super fast. And look how satisfying that is. The treadmill was going as slow as I could possibly get it, like half a mile per hour. And the toothpaste ran out at 4.5 laps. And that's only 40 feet. I don't know if that's impressive or not, so what do you guys think?
Built different.
Alright, let's do a bit of fact checking to see if he's actually built different or if the average human could do the same. There's two parts we need to measure. First, he falls for 23 frames and then his body absorbs the impact in 7 frames. So how long was he falling for? Well, 23 frames times 1 second per 30 frames gives us 0.77 seconds of falling. Likewise, if he absorbed the full impact in 7 frames, that's 0.23 seconds to stop. To calculate his final velocity before impact, we'll use a kinematic relationship. Acceleration is defined as the change in velocity over the change in time, which is 9.81 meters per second squared on Earth. Now we separate the variables and integrate. This is an indefinite integral, so we get velocity as a function of time is equal to 9.81 t plus c, and that c is the initial velocity, which is 0 in our case. Now let's plug in 0.77 seconds to figure out how fast he's going right before impact. This value comes out to 7.55 meters per second. So that's the final velocity right before impact, and since we're now moving on to the impact section, we're going to use kinetics to calculate the force on the body. Now's a good time to take note that it takes about 4,000 newtons to break the average person's femur, which is the strongest bone. That will be what we're comparing to. Anyway, now we'll use Newton's second law, again replacing acceleration with the time derivative of velocity. Just like we did before, multiply the dt to both sides, and we get f dt is equal to m dv, which we can now integrate. This will be a definite integral from 1 to 2, where 1's the starting point before impact and 2's after impact. Is the mass of Mr. Built Different a function of velocity? Well, unless he's burning some crazy amount of calories on the way down, no, it's just a constant and we can take it out. Now we evaluate our definite integral and we can write it as m delta v. The left-hand side of this equation isn't quite as obvious. Is the force a function of time? Let's use a force versus time graph as a tool to help us understand this question. So we're looking at the force with respect to time from 0 to 0.23 seconds when he finally stops. So we're asking, during this impact, was the force changing with time? If we had force transducers on him, would it be a large force at the beginning and less later? Or would it be the other way around? Since we don't know, the best thing to do is to assume that he somehow distributed the force evenly over time. And the total area under this curve represents the momentum change. We'll talk about that in a sec. Since the force here is the same here, the force is constant and we can take it out of the integral just like we did on the right hand side. What we're left with is the force times the change in time. Now we can solve for force, but this force is actually the average force, which happens to be the maximum in our example. The dude in the video is pretty short, no offense, so I'm going to guess around 60 kilograms. I could be off though. So 60 kilograms times 7.55 meters per second divided by our stopping time, 0.23 seconds, and then the units check out. So if he's able to distribute the impact evenly with time, his body only experiences about 2,000 newtons of force, which is much less than the 4,000 needed to snap an average person's leg. But I can't stress the importance of this evenly distributed weight enough. Let's extend this graph for another circumstance where this guy idiotically straight legs it. Immediately upon impact, he's got a much higher force than he does later, and while the area under this curve, representing the momentum exchange, is still the same, the peak amount of force he experienced might be well above 4,000 newtons, and at that point his legs certainly would look different. So to conclude, I wouldn't say he's built different, but I would say he uses some good technique.
Check this out. Lay down. Ah! No, she's fine. Why? Because Barbie knows something about the science of force. I don't want your comments. She's perfectly fine. You know how we know she's fine? Because the balloon is going to be fine as long as we don't use a single nail. A single nail is a single point of force, but 100 nails, that's the secret to distributing the weight. So to prove to you, the next time at a circus or a carnival you see this, watch. We use a balloon like this. Here are the pillars on either side. The balloon goes here. Watch this. We can actually apply a tremendous amount of force. Look at that. And the balloon doesn't pop because it's the distribution of weight. I want you to come up with a great stunt for the bed of nails. Your turn. Don't try this at home. Try it at a friend's home.